Hi everyone, welcome you to the presentation on nodal analysis. This time around, we're going to look at nodal analysis with voltage sources. So if you didn't watch the previous video on nodal analysis with current sources, I would recommend you do just that. Okay, so under nodal analysis with voltage sources, we're going to introduce a term which we are calling a supernode. So by definition, a supernode is basically formed by enclosing a dependent or independent voltage source connected between two non-reference nodes and any element connected in parallel with it. That whole thing will be called a supernode. What do I mean? For example, we've got this circuit. As you can see, there are three nodes here. There is node 1 here, node 2, and node 3. Of course, there is a reference there, which is 0. I'm not considering that one. So you've got node 1, node 2, and node 3 like that. But you realize that between node 2 and node 3, there is a voltage source, which is this one. So this voltage source, since it's sitting between two non-reference nodes, this whole thing now, the voltages together with the nodes together with the voltage itself, they are forming what we're calling a supernode. If at all we had a resistor connected in parallel to this one, that whole thing together with a resistor, it was going to be called the supernode. So when you're analyzing this one, of course, you're going to do your analysis on this node, which is node 1. But here you're not going to do an analysis on node 2 and node 3. You're going to do an analysis on this supernode now. So you consider currents entering this node as well as currents entering that node, leaving that node. So in the supernode, we're going to look at the following. We shall formulate equations from the given nodes. So like here, if you had this one, you formulate an equation according to this node. The other node is the supernode. So you formulate equations from the supernode, which is this one. Actually, it's an equation. And then you are going to formulate what we call a constraint equation. So a constraint equation at a supernode occurs when you have something like this. For example, like here, you've got a node here and a node there, which I'm calling node 1. Let's say you've got a node 1 there and node 2. There is a voltage source like that. This voltage source will be given a voltage. So there will be a given voltage. So that constraint equation is basically the given voltage, which is this one, and the voltages with the polarities where they are connected. As you can see, V1 is connected on the positive polarity. That's why we are saying positive V1. And V2 is connected on the negative polarity. That's why we are calling it negative V2. So the given voltage is basically V1 minus V2. These are just coming from the polarities there. If this one was negative, this one was positive, V1 would have been negative, V2 would have been positive, like that. Then you'll be able to solve the equations with your simultaneous equations according to the equations you formulated. Okay, so we have an example here. The example question is saying, for the circuit shown below, find the node voltages V1 and V2. So you've got three nodes, of course. There is V1, V2, and the reference node. But you realize that V1 and V2 are non-reference nodes, and between them, there is a voltage source. So if you've got a voltage source sitting between two non-reference nodes, and any resistor connected to that, this whole thing formulates what we are calling a supernode. So that is a supernode. So we're doing our analysis on the supernode. So you're supposed to check the currents entering that node and those leaving. So as you can see, the 2 amp is entering, and across that branch we can assume a current is leaving. On that branch we can assume current is leaving, and on here you're seeing the 7 amp there, it's leaving already, it's going like that. So you have that one there. So according to Kirchhoff's current law, it says summation of currents entering a node is equal to those leaving. So on this supernode you only have one current entering, and then you've got those 3 leaving. So with that, we're going to formulate an equation at supernode, and that one will be that. So you've got the 2, which is this one, it's entering, is equal to those leaving. You've got this one here, voltage at higher potential minus voltage at lower potential divided by the resistor, which is V1 minus 0 over 2. Then you have another one, voltage at higher potential minus voltage at lower potential over resistor, which is this one, V2 minus 0 over 4. And you've got the last one, this is a current, 7 amp leaving, which is this one. We formulate that. Okay, so electrical is done actually. Here the only thing is mathematics. You reduce that equation, it's going to formulate that one. So we've got 2 nodes here, non-reference. So we're supposed to have 2 equations. So one of them is this one. Where do we get the other one? We get the other one from a constraint equation. So from a constraint equation, you realize that you have V1 connected on the negative polarity, which is this one, and you've got V2 connected on the positive polarity, which is that one. Constraint equation says that the given equation is basically the voltages with their polarities. So V1 is connected on the negative, that's why we have negative V1. V2 is connected on the positive, that's why we have positive V2, like that. But the voltage has been given, the given voltage there. So the given voltage is 2 volts. So where there is given voltage there, you put 2 volts and you have those. This is going to be our equation 2. So we have equation 1, which is this one, equation 2, which is this one. All we need to do is solve these two equations simultaneously. So when we do our simultaneous equations, having equation 1 and equation 2, I can eliminate V2 by just subtracting 2V1 minus negative V1. It's going to give me 3V1. Negative 20 minus 2 is going to give me negative 22. If I divide both sides by 3, that one and that one, I'll remain with V1. So I'm remaining with V1, which is negative 7.3. Okay, and then you pick any of the equations, either this one or this one, but this one is easier. I make V2 the subject from there. Where there is V1, I substitute that value, and I'm going to have V2 as negative 5.3 volts. So those will be the two node voltages. So it's as easy as that. In the next presentation, I will be explaining mesh analysis. Thanks for watching.